Right, welcome back to Advent of Code 2017. It's been a couple of weeks, I haven't logged in for a while. Hope I still remember how to code. So, we are on day 21. Almost at the end. I might, I don't know. Either 2 streams or 1 stream it will take to finish the lot. So I just need to sort out the chat window. There we go. Okay, so fractal art. You find a program trying to generate some art. It uses a strange process that involves repeatedly enhancing the detail of an image through a set of rules. The image consists of a 2-dimensional square grid of pixels that are either on or off. The program always begins with this pattern. Because the pattern is both 3 pixels wide and 3 pixels tall, it is set out as size of 3. Then, the program repeats the following process. If the size is evenly divisible by 2, break the pixels up into 2 by 2 squares. Convert each 2 by 2 square into 3 by 3 square by following the corresponding enhancement rule. Okay. Otherwise, the size is evenly divisible by 3. Break the pixels up into 3 by 3 squares. Convert each 3 by 3 square into a 4 by 4 square using the enhancement rule. Because each square of pixels is replaced by a larger one, the image gains pixels and so its size increases. Okay, fine. The artist's book of enhancement rules is nearby, your puzzle input. Oh, it seems to be missing rules. The artist explains that sometimes one must rotate or flip the input pattern to find a match. What? Okay. Rows are listed as single units ordered top down. Separated by slashes. I see. For example, the following rules correspond to the adjacent patterns. Rotate or flip. God, okay. How many... Oh my god, okay, fine. Okay. So flipping doesn't doesn't. How many rules do we have? Can I just hard code these? Oh my god, okay. Fine. Oh my god, alright. Yeah, so I can't just hard code them, I need to. Okay. Okay. There's a lot to deal with here. So, okay, I get the process. After 2 iterations, the grid contains 12 pixels that are on. How many pixels stay on after 5 iterations? Oh my god, okay. Might not be as hard as it seems. It's a bit overwhelming. Okay. Fine. Okay, so we need a new. Oops. So, I see. So we need this notion of a. So, this notion of a block, which is a matrix, but it needs to be hashable. So it'll be a tuple of strings instead of a list of lists or whatever. So this will be one big dictionary. Every single possible rotation or flip will be in the keys and map to these. Okay. Well, what do we need to start with? We need so the starting input, the starting pattern is going to be this. So start equals that. So basically we want that. That. Stop putting it. That's the starting block. So we need a table. And in this table, we're going to put all these rules. So let's just left, right equals two parts, this. Okay. Fine, get rotations. Of matrix. We want to output a list of all the small rotations. How do you do this? Let me have a look. You gotta. Ooh, there's a library to do this. Let's see. Let's try this. Oh, it's pip, and it's a. I don't normally use pip things, but this might be convenient. Let's see what else we can do. Oh, you can do it using NumPy, but I can't be bothered to sort out NumPy. All right, so we need to define rotate. This just gives us one rotation, okay? So how does this work? Let's say clockwise. So we've got n equals length of matrix. New mat equals so we want so that how's it gonna look like? So I equals 0, I equals 1, j equals 0, j equals 1. So if you rotate it, then the top row is now going to be whatever was in the first column is now the row. So it goes starting from I equals 0, God, j equals 0, okay, so it'll be, so the original mat, k, the kth row, the 0, hang on, ith row, jth column, for I in range, so it'd be starting from n minus 1, finish at 0. So that's one row. You know what? I'm going to need a class here. All this stuff needs to be contained in a class. There's too much stuff here. Let's create a class. Okay, so we store the matrix here. We say define rotate so okay, so we've got a parameter here. Okay, so the new matrix will be what I did before. ij for I in range n minus 1 minus 1 for j in range self.n. Is there a cleaner way to write what I've written here? Can I not just do self.n dot how do I reversed? Yeah. Okay, and then return matrix new that. Okay. So that's rotate. Okay. I want to be able to print these nicely. So let's do... that. Okay, so let's test this all out. So mat equals matrix start, print mat dot rotate. That looks wrong. First one looks right. Yeah, that's fine. Second one, okay, rotate. New mat equals... So does this row look correct? Oh, Jay and I are swapped. Hang on, how does this work? Jay and I are swapped like this. Try that. No, but it's still... People... There's a missing bracket here. Alright, try that. So I've rotated it to the clockwise. That doesn't look right. Maybe I was... That looks like it's flipped. If I go back to IJ... That's correct. Let's try again. Yeah, that's okay. Okay, we have a rotate method. How about a flip method? So this one's easier. We just do new mat equals tuple, so it'll be let's say we flip vertically. So it will be that. So if I take that out, that is just the matrix, just identity. Is it? Yeah. Okay, so if I swap that to be that, that's just swapping the J left to right. Okay, let's test this now. Can I just... That looks fine. Okay. So now we want get all transformations. Transforms. So let's start by rotating. So so yield a copy of ourselves. Or not quite. Yeah, we could do that. So the identity transformation, and then mat equals self dot rotate what's wrong with that? Okay, so we rotate it, yield that, I'm just going to write this out fully instead of using a for loop. I think I'll just do that. All right, so so we've got rotate once, twice, 3 times. So we've outputted all the rotations. Now, oh no. Rotate, and now we flip. So we're now in the flipped world. Yield that. 1, 2, 3, and then we want to do 1, 2, 3. Alright, how many yields are there here? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's correct. That's all possible rotations and flips. We need a hash method. We also need equality. Okay. That's a lot of stuff here. So let's try this then. For m in mat dot get transforms, print m, just print a new line so that we can see them. So these are all the possible shapes. Looks about right. Yeah, whatever. All right. Good. Next. So we're back to this thing. We've got this input. The left side. All right, let's focus on the. Okay, so output equals the right side. It will be right dot split on the /, and then just tuple that. Create a matrix out of that. Okay. Input equals, that's a reserved keyword, isn't it? Yeah, we don't want to use that. Equals that. Okay, for R in dot get transforms, table R equals output. All right, so we want to see what table looks like now. Okay, it's not gonna end nicely, is it? Just to... that. Okay, so it's saying from the top, there's a lot of them. That maps to... Huh? Okay, fine. Yeah, because that's equal to all its rotations and flips. So that only accounts for one entry in the table. That's what we want. Here... Oh yeah, it's not in any particular order here, so we've got that rotation, that rotation, that rotation. Yep, makes sense. It looks sensible. Alright. What next? So take the starting grid and we perform 5 iterations. So for 5. Okay, so we've got mat, which is our start. And now there's 2 cases. If it's divisible by 2, if mat dot n percent 2 is 0, what are we going to do? Break the pixels up into 2 by 2 squares. How do we do that? Interesting. Okay. We're gonna need another method here. Okay, so divide into blocks of k. What will output is a matrix of matrices. So it'll be like so the output equals so m will be self.n divided by k. So that's if it's 2, then if we divide it into blocks of 2, then m will be half that, and 3 and so on. So we create a new matrix, so it'll be that. Okay, now for I in range m, for j in range m, the ith row of this outer block, the jth column, we have a matrix. Oh man. So the coordinates in the original matrix let's say original equals, oh no, we don't need to do that. So it's k times I. Hang on. So it's going to end up looking like roughly like this, except the ij values will actually be I times k. Wait. No. Plus, let's say y as an alternative to I, j times k plus x. So these offsets, y and x, will range from 0, 1, 2 up to k minus 1. So this one we actually mean x, and this one we actually mean y. Okay. So now we've got a big matrix full of matrices. It's a bit weird. It's fine. Oh. No, that's fine, that's fine. Okay, return output. This is a modifiable list of matrices, which are 2 by 2 or 3 by 3 in this case, because k will be 2 or 3. Man, that was confusing. Okay, so so let's say outer matrix equals mat dot divide by 2. Should I just print this? Have a look at what it's like. Matt is there. Matt is right there. Oh, where's that colon? Else is divisible by 3. So equals. Rep, return non-string. Oh dear. What? Print outer. Outer is... Oh, rep has to be a string. Okay, fine. Just cast it. It already knows how to do that. Okay. So what is this saying? This is saying that is what that looks like when we divide it by 3. What? That's a 1 by 1. That's correct. We get a 1 by 1 outer matrix, just the 3 by 3 block inside it. Good. Okay, next. We want to do the transformation. So we've divided it into blocks. Now, for I in range length, for j in range length, if this block is in our table, we transform. Do our enhancement rules cover every possibility? I guess they must. So it's not a question of if. Okay, fine. So outer I j is equal to the transformation table okay. Similarly here. It's a bit of repetition here, doesn't matter. Try that now. So we've transformed it. So we started with this dot hash dot 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 hash 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 hash. We transformed it to that. Is that correct? We need to find this pattern. It would be dot hash dot 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 hash 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 hash. So yeah, but it could be rotated or something. All right, well, let's assume it's correct. Okay. I mean, I don't think we need to do all this here. Let's make this a method. So we say transform via this parameter here, k. Right. So out is now this outer matrix. So now we just take this logic here, put it here. Well, when we get this matrix here, we can immediately say table needs to be defined at the start. Okay. So now out has the transformed version. Okay, this is a cleaner way of doing this. Mat equals mat.transform to if mat.n send2 equals 0, else 3. And we can literally just do that. Alright, but it's not going to do anything right now. It's going to crash actually because we haven't outputted anything. Alright, so we've got a transform. We've now got the expanded matrix, but we need to tie it all up again. So we've now got a matrix of matrices. We want to tie it all up. Each row will be top row of each of the what? Okay, new mat equals, let's say it's just a list, right? So we want to do a list of strings. So for I in range M. So that takes outer row of blocks for, let's say, Y in range length of the inner matrix. New mat.append we want out I J that would God. So that gets us this matrix. And then what? We want the y-th string. And this ranges over the outer j values. So that'll get us a specific row of every inner block. Now I'm starting to think if I just use numpy, this all would have all been way easier. So new mat, okay. New mat equals, okay, so it's now, so just return a matrix of a tuple of this new mat. So just change the list to a tuple, turn it into a matrix. Mat. Okay, let's try that. Matrix has no length. Ah. Join. Generator found. Uh-oh. Uh-oh. Where did I create a generator instead of a tuple? Mat equals mat.transform tuple. Every time we've used matrix, we've used it on a tuple, right? That is a tuple of strings. Done that, haven't we? This is after the first transform, so let's just try printing this, see what it looks like. That should just be a list of strings. Generator object. Bunch of generators. Oh, again, I put the brackets in the wrong places. There we go. God. Alright, okay, I've got something here. So we start with that, transform, we get that, transform, we get that, transform, we get that. I mean, the fact that it's not crashing sort of indicates that it's may well be correct. Because if you do anything slightly wrong, I feel like this is just going to crash. Okay. What do we want? Oh, we want to find how many pixels are on. In other words, how many hashes there are on this final thing. Okay, so we've now got a final matrix. Print sum of row.count hash for row in mat strings. Tuple what? Road for row mat dot mat dot. There shouldn't be brackets there. There we go. 120. It's a very round number. That's not a good sign, but. Okay, that's correct. So, how many pixels stay on after 18 iterations? So we just changed 5 to 18. Interesting. Okay. Let's just do this then. Change that to 18. But if the 5th iteration, print that, and print that. That's after 18. This won't take that long, will it? It's only increasing by 1. Oh, it's increasing by like 20 to 30% each time, but still, 18 iterations, that should be fine. I shouldn't be printing all this though, that's bad. Okay, nice big number. I mean, this should work. There's no reason why this wouldn't work now. If it worked for 5. Correct. Wow. It took a while. But, I mean, you need to decode all the different fiddly bits. Right, let's see ChatGPT do it. I think ChatGPT will be fine with this. It's one of those things that's not technically difficult, just a bit fiddly. Okay. Let's see. He has a cleaner way of doing rotations. He's got... He's keeping the / in there instead of... Okay, fine. It's got error handling and... Alright, let's test it out then. We're expecting 120. It looks like he's parsing it correctly. Got invalid pattern size. Tell me what pattern size you're getting. It doesn't actually print pattern sizes you're getting. Alright, well, let's just tell him that. I don't understand what he did wrong though, because I did have that format, but right, whatever. Combine subgrids. Okay, it's correct. Alright, I know how to change this for 18. I'll just change it in the code. (2204099). Yep. ChatGPT wins, as always. Right. Okay, so what are we on? 22? Should I move on? And that will leave 2 problems and 2.5 problems left for next time if I do this one. Sporific virus. Let's have a look. Okay. Something to do with moving around simulation. I'm not sure if I have time. I need to have lunch, and it's 2 PM already. Yeah, I'll stop there. Carry on next time. So we've got 22, 23, 24, and 25. 25 is just a part 1 only. That's the tradition. At least I believe that's the tradition. Ooh, Turing machine, fun stuff. I shouldn't take a sneak peek. No sneak peeks allowed. So yeah, okay, that was just problem 21. Let's have a look at some stuff. 21 was this one. 10 minutes to solve. I mean, it's not actually. If you've got some methods prepared for dealing with matrices, I mean, NumPy probably has really easy methods for doing stuff, common stuff like combining subgrids to create a one big grid and so on. So yeah, there's probably easier ways of doing it. "41 minutes? How long did I take?" About 1 hour, 5 minutes or something. Yeah. Cool. I thought that was a nice problem, actually. I need practice with that sort of stuff. Matrices, rotating, flipping, doing stuff like that. That's actually pretty important stuff. I should really learn how to do it using NumPy, to be honest. It's about time. I haven't touched NumPy in so long. This one looks fun. Some sort of simulation around a grid. Okay. That's it for now. Alright. See you next time with day 22.